Okay, finishing this guy up. So just recapping first of all. It had to be a U substitution because I have a composition of product that I couldn't easily simplify. I let U equal the inside, calculate du, solve for dx. I went ahead and calculated my new limits because that's what I think is easiest to do. And so you just use your substitution and figure out the U values. So my substitution was 1 plus 2x, so if x equal negative 1/2, plug into the substitution, I get 0. If x equals u, plug in the substitution, I get 1. Then I started doing my substitutions. Initially, there was still an x squared term. I couldn't really do anything until I got rid of the x squared term. So I did that by taking my substitution, solving for x, plugging in, and I finally got down to here. Need to simplify. Product. But I can simplify this. So just multiplying this first guy out here, that's going to be u squared minus 2u plus 1 over 4 times u to the 10th du. That 4 can come out and join that 1/2 for 1/8. And that u to the 10th can distribute. And so I'm going to have u to the 12th minus 2u to the 11th plus u to the 10th du. And now, finally, I'm ready to integrate this thing. And so 1/8, increase the exponent by 1, multiply by the reciprocal of the new exponent. Let's go out just a little bit so you can see more on one page. There we go. Increase the exponent by 1, multiply by the reciprocal of the new exponent. Increase the exponent by 1, multiply by the reciprocal of the new exponent. Increase the exponent by 1, multiply by the reciprocal of the new exponent. Evaluated from 0 to 1. Remember this part right here checks by differentiation. But remember, it's only going to check back to this step right here. It's not going to check all this work up here. But you can check that part. And there is absolutely no need to substitute back to x. And think of how much work I have saved myself by not having to substitute back to x. It's still up here that u equals 2x plus 1. If I hadn't bothered to calculate these new limits, these were the limits with respect to u. If I didn't have those new limits, I would then have to take this 1 plus 2x, replace all those u's with 1 plus 2x, which makes it more complicated. U is easier to work with than 1 plus 2x. But I would replace all those u's with 1 plus 2x, and then remember what the original values were. The original values were 0 and negative 1/2. I would have had to work with a negative 1/2. And so I would have found myself, if I didn't have this 0 and 1, I would have found myself with 1 plus 2x in each place and then working with a 1/2. Now doing my evaluation, I prefer to work term by term. So 1 to the 13th minus 0 to the 13th minus 1/6, 1 to the 12th minus 0 to the 12th plus 1/11th times 1 to the 11th minus 0 to the 11th. And so I get 1/8 times 1/13th minus 1/6 plus 1/11th, and whatever that works out to be. Like I said previously, but I only said it once, the arithmetic on the end is not the point. So if you get up to here with a correct statement that would lead you to the correct answer, if you just bobble your arithmetic down here, I am not going to care unless it's trigonometry. If it's trigonometry, I grade everything. But the point is not the arithmetic. But I have to see a correct statement here with correct use of parentheses, whatnot, need a correct statement. Now, I prefer to work term by term. If you prefer, you could plug 1 into the whole thing, plug 0 into the whole thing, and subtract, whichever makes you happiest. But there's that guy. Okay, we have one last thing, or I guess there are two things left, and we'll see if we can get it on this video. Definition, the average value of a function. The average value, we should zoom in a little bit so we can see that a little better. There we go. The average value of the function, if y equals f of x is integrable on the closed interval of a to b, then its average value on the closed interval a to b is given by AV of f. And that's just your book's notation for average value. That's going to vary from book to book, but the formula is not. The average value is given by 1 over b minus a times the integral a to b of f of x dx. Note, the average value of a function is also sometimes called the mean value. Now, comment on the homework. When doing the homework in my math lab or my lab math, as the case may be, do not click on View an Example. View an Example uses Riemann sums. Do not use Riemann sums unless instructed to do so. There's really no reason, now that we have the fundamental theorem of calculus, there's really no reason to go back to Riemann sums, and so I actually pulled these problems out of a different section and put them here, so just be sure you don't use Riemann sums. Find the average value. So we're just going to apply that formula, that the average value, AV of f, the formula is 1 over b minus a, the integral from a to b of f of x dx. So in this case, 1 over the natural log of 5 minus the natural log of 3, the integral from natural log of 3 to the natural log of 5 of e to the 2x dx. And we just work it out. So 1 over the natural log of 5 minus the natural log of 3. And then you just got to remember everything we learned about indefinite integrals before, that the integral of e to the x, or e to the mx was itself, then the effect of that slope, when we had linear arguments, the effect of that slope, every single time when we integrate was to divide by it. Because if we were differentiating, the chain rule would have us multiply. Well, integration's the opposite of differentiation. So if in differentiation I multiply by the 2, when I integrate I divide by 2. And then evaluated from the natural log of 3 to the natural log of 5. And now I just start doing the evaluation. So that's going to be 1 over 2 times the natural log of 5 minus the natural log of 3. Just bring that 1/2 out in front. And then that's going to be e to the natural log of 5 minus e to the 2 times the natural log of 5 times 2 times the natural log of 3. And we're going to simplify this. And I would want you to simplify this. Please recall the natural log of e to the x is x. That natural logs and natural exponentials were inverse functions, and when I compose them, because they're inverses, they quote-unquote cancel. They undo each other. But, and the same thing for the other way, should have written down the other way, the one that's going to be important, same thing, e to the natural log of x is x. But the e and the natural log have to be right next to each other. They have to be touching. And so I can't use this until I get these guys to touch. And that's not a particularly mathematical precise thing, but you know what I mean. The e and the natural log are exactly are side by side. Well, I can use properties of logarithms. If I remember this, r times the natural log of p is natural log of p to the r. I can use my properties of logarithms to rewrite that, and now I can use my inverse property of e to the natural log of x is x. And so that's 1 over 2 times the natural log of 5 minus the natural log of 3. And then that would be 5 squared minus 3 squared. Well, that's 25 minus 9. 25 minus 9. And what, 25 minus 9 is 16, so that'd be 16 over 2 times the natural log of 5 minus the natural log of 3. And I would be perfectly and wonderfully happy with that answer. Well, not quite. I would expect you to say that's 8. Then, willing to bet anything. Now, I would be happy with the 8 and the natural log of 5 minus natural log of 3. I'd be happy with that. But willing to bet anything. Well, not true. That's not true. I'm not willing to bet anything. I'd be willing to bet a quarter or so, maybe 50 cents, maybe even $1. That the computer's going to go that way. That's the natural log of 5/3. Using the quotient rule for logarithms. That the logarithm of a quotient could be split up by subtraction, or going the other way, subtraction of 2 logarithms could be put together by making a fraction. And that's what I would guess the answer was going to be. I don't care if you do that. Do want to see the 2 divided by 16 is 8, but I don't care about that one. So there is an average value. Got another average value problem on the next one here. Find the average value. So you start with the formula. V of f is 1 over b minus a, the integral from a to b of f of x dx. So in this case, my average value is going to be 1 over 1, excuse me, got those backwards, square root of e minus 1, the integral from 1 to square root of e, 6x over 4 plus x squared dx. You can't see that. Let's make that so you can see it. And so we got to decide how to integrate that. So you might see that 4 plus x squared, and you're thinking, inverse tan. I know that's inverse tan. She reminded us about inverse tan. I know that's going to be inverse tan. But here's inverse tan over here. Notice the numerator is 1, or a constant. It doesn't have to be 1. And then the inverse tan problem we did. All right, here's the inverse tan problem we did. We had 3 over 1 plus 3x, or 3 over 3 plus x squared. So this is close to inverse tan, but the fact that I do not have a constant in the numerator, I've got 6x in the numerator and not a constant, it isn't going to be inverse tan. Inverse tan has a constant up there, so it's not inverse tan. So I've got to make it look like one of the fractions I do know. So we know it's not going to be inverse tan, and there isn't a good way using negative exponents to make it a non-fraction. The other, sine inverse, that has a square root. There's not a square root here, so it's not going to be sine inverse. The only other fraction that we got, right over there, and you just barely see it. Let's zoom in on it a little bit. There's no reason why we shouldn't zoom in on it. The only other fraction, go away. There we go. The only other fraction that we know about is 1 over u du. So it's not going to be sine inverse because I don't have a square root. We decided it's not going to be tan inverse because I have to have, for tan inverse, I need my numerator to be a constant. It doesn't have to be 1 because I can factor out anything, but it needs to be a constant. The only other fraction I really know about is 1 over u du. And so that's what I'm going to have to try for here, because there's no way to simplify this to a nice non-fraction with a negative exponent. It's going to have to be 1 over u du, which is what we will do in the next video.